Today we've got furnace problems, every homeowner's nightmare. Our thermostat is calling for heat, but the furnace isn't kicking on. Let's figure out why. We're down at our furnace. This is a 9-year-old forced air Trane unit. Let's see if we can figure out what's going wrong. Okay, the first things we want to do are eliminate the simple items. Your furnace does need electrical power. Most units have a switch on the side here, and make sure that's on, and then we can come to our indicator light here, which is a blinking LED on the control panel, and it will not be blinking obviously if you do not have electrical power. So we've got electrical power to the controls. The other thing this light does, it'll flash warning signs depending on the sequence of blinking, and that will be in your manual. This one is currently blinking such that it's saying it's in good condition, there's no problems. So that does not give us much of a clue as to what's going on. The other thing that could affect you is obviously you need gas pressure. So our valve is open there on our gas train, and our indicator light would be blinking a code for low gas pressure if that's why it wasn't operating. So we need to dig a little deeper here. So now we need to take our covers off. We'll turn our electrical power off for this. All right, here we go. We've exposed the workings of our furnace. Looks a little overwhelming with all these wires, but it's really not that bad. Our control panel's here. Behind it, we've got our big fan for air circulation throughout the house. Over here is the air intake where we put our filter. Moving up, here's our burner components. So our gas train feeds in here to our shutoff valve, which then feeds into the burner assembly. And here we've got our combustion blower, which provides air. So our combination of air and gas and spark is what gets our flame going. So now that we've got this exposed, I'm going to cycle the power and just observe what happens. So this is a safety switch. This panel needs to be on for operation because we're troubleshooting. We'll bypass that here. So we've got power to our control panel. I heard that click. And I don't know if you can hear that. Ooh, we found the problem. I hear a humming coming from our combustion blower motor, and it's hot to the touch. So for some reason, we're not getting rotation in this. So we'll take power off, and I know right away I need to replace this combustion blower. Could be the capacitor in it. We'll have to search for parts and see what we can find. But we will see if we can get a temporary fix right now. But the reason we won't fire up here, it's a safety concern. This combustion blower needs to purge all of the air in the burner assembly to make sure there's no gas buildup that could create an explosion. Okay, as a temporary fix, often it's not a good situation when you don't have heat. It's the middle of January, we need to get some heat on before I've got access to this. So I've got a normal hammer. Just gonna give our motor some gentle taps there and put power back on. Okay, it hummed louder, but it wasn't enough to get it going. Unfortunately, there's not much shaft exposed here to grab onto and turn. Often these motors get kind of a dead spot in there and they won't allow them to rotate. So if we can move it, manually rotate it to a different position, it might be enough to get us going temporarily. All right, I got it to rotate a little bit with a pair of very fine needle nose in a little bit of the exposed shaft there. Let's see if that's enough. All right, so that told us a couple things. We've got a bad spot in it. We can hear the bearings may be out on this. Our rotor is probably rubbing on our plastic housing. So we don't want to just replace the capacitor. This whole unit needs to be replaced. There are some part numbers on here, so we're gonna copy these down and see if we can locate a spare one. But we'll do another couple rounds of testing, make sure overnight here we've got power. The other thing, we've got some additional model numbers for our furnace. So that's all great information when we start looking for replacement parts. Let's see if we can, this motor will fire up again. All right, it does not sound good, but at least we've got a temporary fix and we don't need to emergency call a heating specialist in. This will get us through the night. We'll find ourselves a new combustion blower assembly and get it swapped over. All right, I was able to get the part. It's called a draft inducer, not a combustion blower, as I said before. Combustion blowers go before the burner assembly. Draft inducers go after, basically to induce a draft in the burner assembly and then expel the exhaust out. So this thing I did find on Amazon, and it wasn't Prime available, so it didn't have fast shipping. It was about 5 days, and instead of risking days without heat at this time, I called around local heating supply companies, and one of them had this in stock, so I just went over there and picked it up. It's not cheap. This $500 assembly basically would have saved maybe $50 on Amazon, but decided to not risk it. $50 would seem awful cheap if you're sitting around in a cold house worried about your pipes freezing. Anyway, we'll get this baby on. We'll get the other one off and put this thing on. The first thing I'm gonna do is shut off electrical power at the furnace. We'll close the gas valve too, what the heck. I'm also gonna turn off the breaker to the furnace. Since we're replacing an electrical part, I wanna be extra safe, make sure we don't fry that control board, or myself. Well, we have to open our furnace back up. And we can start disconnecting the electrical connections. We see the wires are color coded here, so we can't mess that up. Our green is the ground. That simply has a sheet metal screw to the sheet metal to ground it. Our white is power. That has a simple connection here. We have to pry out with a small screwdriver. Then this is our safety device that ensures rotation of the assembly before it allows startup, which in this particular case was obviously required. That kept the furnace safe. Would have been bad news if this thing was stuck and it would allow it to fire up. All right, and then we have, from the safety switch connector, we've got one of the wires going to the motor that we have to remove. That's where our instructions on the paper come in, but we need a small flat blade screwdriver and we need to put it inside the connector and pry down a plastic catch that's in there and pull out our wire. There we go. Once you get your screw, don't pull very hard. Once you get your screwdriver in the right spot, it'll come out pretty easily. So we'll just let that hang down here. We've got our wires disconnected. We do need to reuse the safety switch. So I'm just gonna take a Phillips screwdriver and remove the screws right here in place. Easy to work on when it's mounted tightly. Pretty simple device. I'll set that right there and reinstall it on the new blower. Then we have our exhaust pipe connection here. There's just a hose clamp on that, which, hey, look at that, it's loose. And so we got to loosen this hose clamp, move that up out of the way. Then we also have a drain tube coming from the bottom with a pinch clamp. So we'll just take a pair of pliers, pull that clamp back, then pull the drain hose back. Could have done that by hand, but these sheet metal edges are sharp. So either wear a pair of nice cut resistant gloves or wear some tools to reach in there. It'll slice yourself open pretty good if you don't. Now we've got everything disconnected. There are mounting sheet metal screws mounting it here. There's 3 of them. So we'll remove these. Then our blower should be free to take out. There's what those screws look like. So what this draft inducer does is we've got our heat exchanger here, primary, secondary, and it's pulling the combustion product, so exhaust, and exhausting it out. A big part of exhaust is water vapor, so it's not uncommon to see that in here. You should at the same time make sure this drain tube is open and draining properly. So a good thing to do off our manifold back here is to pull this drain tube off and make sure that it's completely clear and that your drain to your floor drain coming off, here's where it comes off this main manifold block, is also clear. If you get a buildup of water in this system, it's gonna, that fan isn't gonna like that. When you're searching for a replacement part, look for this sticker. This is the original blower motor. We can see number there, and this larger number is actually the part number I found and used. That starts with a D to find a replacement. That seems like the most commonly used part number for this. If we look at the new one, has a little different markings. Fastco is the company that actually makes this and supplies it to Trane. Interesting. But anyway, here is our replacement unit. We'll get this thing in place. Don't forget your hose clamp here for the exhaust. Now once you get it on the exhaust, you got to line up the holes. There's a pilot on the back that you need to line up, but we'll get our large sheet metal screws in place so it holds us approximately where we need to be. All right, put our wiring back together, ground cable, our motor wire, and we'll put our safety switch back on. On all of these things, it's important not to over tighten them. We're just dealing with plastic and sheet metal, and if you over tighten things, it will strip up quickly, and that'll be a bad day. We'll put our drain tube back on the bottom. Now, we have to put our safety switch connection back together. That is just a matter of pushing this wire back in. Then we'll plug it back in. Moment of truth here. We've got power, we've got the breaker back on, power back. We'll hit our switch. Our new draft inducer is working perfectly. But our furnace is not firing. Why is it not firing? Well, it's not firing because I forgot to turn the gas valve back on. Okay, now we should be in business. All right, now that our gas is on, take two. Draft inducer's coming on, sounds nice and quiet. You can hear our flame starting. There it is. We've got full flame. Mission success. Whenever something like this fails, I like to do a little bit of a failure analysis to see if I can prevent it in the future, or just for my own curiosity. Maybe there's a way I can kind of repair this a little bit and have it as a backup if it happens in the future, to prevent me from having to spend another 500 bucks. So the first thing, I'm just gonna spin the rotor here. And what I thought was maybe motor or bearing damage, actually isn't. There's a impeller, basically the fan blade, on this kind of squirrel cage type blower assembly, and it sounds like that is hitting the plastic housing. So let's take this thing apart and see if we can see anything. There's a split line down the middle with some screws here. We'll pull that apart and see if we can determine anything inside. No major signs of wear in this half. There is a little bit of a witness here. This material looks to be a glass-filled nylon, very common polymer plastic to use in structural applications. The rubbing appears to be on this side, and it's not on the outer diameter, and it just went away. Something fell. What the heck is that? A little piece of dirt. It looks like rust. Yeah, definitely looks like iron oxide. What the heck? Oh man, now I don't hear anything. Now it's interesting, there is evidence of wear on this surface, but there's definitely no clearance issues on the housing. There must have been something else in here at some point that caused this. And then a piece of rust somehow got on the inside of that rotor. Well, I should have taken that part before. I could have saved myself $500, but if you watch this video and you're having the same problem, take this out, take your fan apart. There might be just some debris in there that's causing it to get hung up in certain spots. So after putting this back together, the other half of the housing, it is still making a noise. There's still some rubbing. It must be between this half of the housing that I took off and the impeller. Likely what that is, this assembly, all the plastic parts are glass-filled nylon. Nylon is a great engineered material to make structural plastic parts out of. The one drawback that it has, it absorbs moisture and swells over time. So I'm thinking likely what happened is this operating in a moisture-rich environment, that combustion gas has a lot of water in it. As we could see when we took the old one off, there was a lot of water that kind of drains through this assembly out the bottom. In that environment, everything here absorbed that moisture and the impeller swelled, and the original clearances that were good are gone now. So I will keep this as a spare. Maybe over time it'll dry out and kind of shrink back down. We'll see. I won't sell it because it isn't quite right, but I'll keep it as a backup in case there's a problem with the other one. If you found any value in this video, please consider subscribing to my channel. Hit the like button on this video. Thanks for watching. Adios.